Yes, good morning, children. Now we'll continue with this limits. Today we'll learn infinite limits. In infinite limits, there is one point to learn as x tends to infinity. Till now, we solved the problems where x tends to 0, x tends to 1, 2, 3, a like that. Now it is x tending to infinity. In such problems, what we do is we'll put x is equal to 1 by y. Put x is equal to 1 by y. Then what is y? Y is equal to 1 by x. What y is 1 by x. Now x tends to infinity implies that 1 by x tends to 1 by infinity. 1 by infinity means 0. So that means y tends to 0. So I can just learn these two. Put x is equal to 1 by y. X tends to infinity implies y tends to 0. So now you can convert to y tending to 0, and as usual we solve the problems. Okay, now one problem will do like this. First one, limit extend. I'll do by two methods. Limit extending to infinity of 3x square plus 4x plus 5 by 2x cube plus 3x minus 7. So here we have extending to infinity, no? So we'll write all this. Put x is equal to 1 by y. X tends to infinity implies y tends to 0. Y tends to 0. That is enough. You need not write all the that in full. Okay. Now this is limit y tending to 0 of. Now we'll write everything in terms of y. 3 into x square. X square means 1 by y square. Plus 4 into 1 by y. Plus 5 by 2 into 1 by y cube. Plus 3 into 1 by y minus 7. Now this is our function. Now we'll take LCM, simplify. Y tending to 0 of 3 plus 4y plus 5y square by y square by 2 plus 3y square minus 7y cube by y cube. Okay, y cube. Here only y is there, so y square. So y cube. Now this y cube goes to the numerator. So it is limit y tending to 0 of 3 plus 4y plus 5y square by y square into y cube by 2 plus 3y square minus 7y cube. Now this y square and another y cube, y will be left over. So now substitute y as 0. So this is 3 plus 0 plus 0 into y is 0 by this is 2 plus 3 into 0 minus 0. 7 into 0, 0. So now what is this? 3 by 2 into 0. 3 by 2 into 0. 3 into 0 is 0 only. So it is 0 by 2. 0 by 2 is 0 answer. So it is not indeterminate. It is not 0 by 0 form. It is 0 by 2. So like this we do. This is one method. You are putting x as equal to 1 by y and doing. Another method is without substitution also. You can do like this. You take the highest power of x common from both numerator and denominator. You take x square common. Then it is 3 plus 4 by x plus 5 by x square. You can see when you multiply, you are getting 3x square, 4x like that. So from denominator, you take x cube common. X cube into 2 plus 3 by x square minus 7 by x cube. So x tends to infinity implies 1 by x tends to 0. Without any substitution, you will write 1 by x tends to 0. So here x cube gets cancelled. X square gets cancelled. So you'll get 1 by x into 3 plus 4 by x plus 5 by x square by 5 by x square by here it is 2 plus 3 by x square minus 7 by x cube. So you can see 1 by x tends to 0 now. So this is 0. So is equal to 0 into 3 plus 0 plus 0 square is 0 by again 2 plus 0 minus 0 like that. So it is 0 by 2. 0 by 2 is equal to 0. Like this also you can do. Without any substitution also you can do like this. So the highest power of x in numerator and denominator you take outside common and try to simplify. Okay, this is the method to find the infinite limits. So it is better to use the full substitution method. Put x is equal to 1 by y and do. Then you will not have any confusion regarding putting 0 or y or whatever it is. Okay, next problem. Second problem. Limit x tending to 2 of x square plus 2x minus 1 by x square minus 4x plus 4. Here it is not extending to infinity, extending to 2 only. So when you substitute, we'll see what is it. 4 plus 4. 8 minus 1. It is not 0. So it is 2 square plus 2 into 2 minus 1. Direct substitution only then. Minus 4 into 2 plus 4. So you can see this is 4 plus 4. 8 minus 1. 7 by. This is 4 plus 4. 8 minus 8. 0. 7 by 0 means infinity. So like this you have the infinity limit value in the problem. Any number by 0 I gave in the first period. It is infinity like that. Okay. Now next problem. Okay, these problems you can try. Now this problem is very important. Limit x tending to infinity of 8 into mod x plus 3 into x by 3 into mod x minus 2x. This problem is very important. So you must write this step, very important. So as x tends to infinity, x is tending to infinity means what? For mod x, what is the definition? Mod x is x when x is positive, minus x when x is negative. You have learned the definition. So is x positive or negative here? X is tending to plus infinity. So that means what? X tends to infinity implies that x is greater than 0. It is positive only. So that means mod x value is x. First you must remove this mod x. You must write mod x as either x or minus x. Then only you can simplify the function. So according to the limit value, we found that it is positive. So its value is x only. So therefore limit x tending to infinity of 8 mod x plus 3x by 3 mod x minus 2x becomes limit x tending to infinity of 8 into x only, that is 8x plus 3x by 3x minus 2x. Very simple problem. But this step is very important. You have to write this. If you directly write, you won't get any marks for this. So this is limit x tending to infinity of 11x by x. 11x by x is 11 only. 3x minus 2x is x only. So limit of any constant number is that constant only. Whether it is infinity or 0, whatever it is. So answer is 11. So the answer is 11. 11 by x. X and x gets cancelled. So the answer is 11. Okay, next problem. 3 problems. Okay, next fourth problem. Okay, fourth problem. Yes. Limit x tending to 2. Limit x tending to 2 of 1 by x minus 2. This is again very important. Very important problem. Minus 4 by x square minus 4. Okay, now when you substitute 2 here, what happens? This is 2 minus 2, 0. 1 by 0 is infinity. And here also it is 0. 4 by 0. Infinity minus infinity. Indeterminate form. So what is to be done here? So you must simplify the function. So limit x tending to 2 of, we'll take LCM and all. So here you have 1 by x minus 2 and here you have x square minus 4 will write as x minus 2 into x plus 2. X plus 2. Now we'll take x minus 2 common. X tending to 2 of 1 by x minus 2 common. Then what is left here? 4 by x plus 2. Now take LCM and simplify. So this is limit x tending to 2 of when you take LCM, what is it? 1 by x minus 2 into x plus 2 minus 4 by x plus 2. So very simple here. So this is x minus 2 gets cancelled. Now you can just substitute the limit x tending to 2. So you get the answer as x minus 2 into, this is x minus 2 by x plus 2. So x minus 2 gets cancelled. So you will have limit x tending to 2 of 1 by x plus 2. So just to substitute to 2. So it is 1 by 2 plus 2, that is 4. 1 by 4 is the answer. So like this we do the problem. Okay, next problem is again very, very important. This problem, fifth problem, is very, very important. Limit x tending to infinity of root of x plus 1 minus root x. So it is again infinity minus infinity form. This is also infinity minus infinity. So indeterminate form. So what is to be done? Because you have root x and all, you can rationalize. So limit x tending to infinity of root of x plus 1 minus root x, multiply and divide by root of x plus 1 plus root x by root of x plus 1 plus root x. So when it is in the form a minus b into a plus b, a square minus b square. A square means root will go, so it is just x plus 1. A square minus b square is minus x by root of x plus 1 plus root x. So now this x will get cancelled. So it is limit x tending to infinity of 1 by root of x plus 1 plus root x. You can substitute infinity, or you can write put x is equal to 1 by y like that. Or you can write limit x tending to infinity of 1 by, if I take root x common, it is 1 plus 1 by x. And this is root x. So I'll take root x common. So it is equal to limit x tending to infinity of 1 by, if I take root x common, it is 1 plus root of 1 plus 1 by x plus 1. So this is 1 by root x is equal to limit x, I'll write here. Or you can write 1 by infinity, which is equal to 0 like this. So anyhow this is infinity, infinity plus infinity, infinity. So 1 by infinity is 0, you can write. Or else you do like this, is equal to limit x tending to infinity of 1 by root x into 1 by root of 1 plus x, yes. 1 plus 1 by x plus 1. As x tends to infinity, 1 by x tends to 0. X tends to infinity will change to 1 by x tending to 0. So 1 by root x also tends to 0. So this is equal to, this is 0 into 1 by root of 1 plus 0 plus 1. So 0 into any, this is a finite number. So it is equal to 0. So like this you can do the problem. Now next problem, next one is again similar to this. So limit x tending to infinity of root of x square plus x minus x. Similar to this. Here root is not there. So same procedure. Limit x tending to infinity of, you can put x as equal to 1 by y and try. X square plus x minus x, multiply and divide by, rationalize. Root of x square plus x, multiply and divide by root of x square plus x plus x. So now this is in the form a minus b into a plus b. Same procedure. You can try, or else we'll do complete. Is equal to limit x tending to infinity of a minus b into a plus b. A square minus b square means x square plus x minus x square by root of x square plus x plus x. So here x square gets cancelled, and then x square gets cancelled. So it is limit x tending to 0 of x tending to infinity of x by root of x square plus x plus x. So we can take root x common, or else shall we take y as put x is equal to 1 by y, and we'll do one problem. We'll try like this: put x is equal to 1 by y. X tends to infinity implies y tends to 0. Okay, so this becomes limit as y tends to 0 of x is 1 by y. So 1 by y by root of 1 by y square plus 1 by y plus 1 by y. So now this is limit of y tending to 0 of 1 by y by root of, this is 1 plus y by y square plus 1 by y. So what happens, this y square becomes root, when you take it becomes y tending to 0 of 1 by y by root 1 plus y plus 1 by y. Root y square for denominator, it is y. Taking LCM, it is y. Y also gets cancelled. Now it is equal to, so it is equal to limit y tending to 0 of 1 by root of 1 plus y plus 1. 1 plus y plus 1, this is y. So what happens, this now substitute y as 0. So it is 1 by root 1 plus 1, that is 1 by 2, like this. So you can try the earlier problem also like this. Put 1 by y and you can try. Okay, next problem. Now what is this problem number? 6 or 7. I missed the problem number again. Okay, next problem. Next we'll do problems based on sandwich theorem. Okay, you can take down these homework problems so that I can know what are all left out. Homework problems, you can try these problems. Limit x tending to infinity of 3x to the power 5 minus 1 by 4x square minus 1. The answer is infinity. Okay, next. Limit x tending to 3 of x square plus 3x plus 2 by x square minus 6x plus 9. So when you substitute, I think you may get some number. It is not infinity problem. Okay, next is limit x tending to infinity of 6x square minus x plus 7 by x plus 3. So the answer here is infinity. Infinity, you can take x common like that, or put x is equal to 1 by y. You will not have any doubt there. Whenever you have x tending to infinity, put x is equal to 1 by y and try. Root of x square plus 6 by 2x square minus 1. So here the answer is 0. Next, these are all very simple and easy problems. Limit x tending to infinity and important problems. X square plus 5x plus 2 by 2x square minus 5x plus 1. So the answer is half. Okay, limit x tending to minus infinity of 2x square minus x plus 3 by x square minus 2x plus 5. So the answer is 2. Okay, you can try all these problems. Okay, next, still we have time. Okay, so we can do some more, 2 important problems we'll do. We have sandwich theorem. You can try all these problems. One more problem is there. Okay, I'll write this also. 7th problem. Limit x tending to minus infinity of, all these are there in exercise 8D. Exercise 8D problems. 5x cube plus 4 by root of 2x power 4 plus 1. So the answer is minus infinity. Okay, you can try these problems. Now next we have the sandwich theorem. What is this sandwich theorem? If f, g, h are three functions, then suppose that f of x is less than or equal to g of x is less than or equal to h of x. Then if suppose these are the functions, they have domain and all. If limit limit x tending to any a of f of x is equal to the limit x tending to a of h of x is equal to L. If these two limits are same, then this limit should also be equal to that value. Then that is the theorem. Then limit x tending to a of g of x is also equal to L. If the limits of these two are equal to L, then the limit of the middle one is also equal to L. That is the sandwich theorem. Now we'll do some problems based on this. So find the limit. All these problems are compute. So these are all compute. Find the limits of all these functions. Okay, next. Limit x tending to infinity of x square minus sin x by x square minus 2. Now we'll do this problem. Here, if you take x as 1 by y, there is no use because you have sin x. So you cannot use that method, put x is equal to 1 by y and all. So what we do is, we'll reduce this to this form. We have sin x. So what we do is, we know that sin x lies between minus 1 and 1. We know that sin x lies between minus 1 and 1. Now minus sin x multiply by minus 1. Then it becomes minus sin x. This becomes plus. So 1 is greater than or equal to minus sin x is greater than or equal to minus 1. We are multiplying the whole inequation by minus 1. So this becomes plus and this is minus sin x minus 1. So inequation signs will change. Now again bring it to this side. Then it becomes minus 1 less than this. I am writing here this that side. Then again the directions will change. So minus sin x is less than or equal to 1. Okay. Now we should get this function. So add x square on both sides. So now we'll add x square to the whole inequation. So adding x square, it is x square minus 1, x square minus sin x is less than or equal to x square plus 1. Now we should divide by x square minus 2. So x square minus 1 by x square minus 2 is less than or equal to x square minus sin x by x square minus 2 is less than or equal to x square plus 1 by x square minus 2. Now we will take the limit. So we will take limit to the whole inequation. Limit x tending to infinity of x square minus 1 by x square minus 2 is less than or equal to limit x tending to infinity of limit x tending to infinity of x square minus, okay, I'll draw a line so that we'll not confuse with the steps. X square minus sin x by x square minus 2 is less than or equal to limit x tending to infinity of x square plus 1 by x square minus 2. Now you know how to find the limit. You can put x as equal to 1 by y or take x square common like that. So if I'll take x square common so that 1 by x will have, and you can 1 minus 1 by x square. And here also I'll take x square common. 1 minus 2 by x square. As x tends to infinity, 1 by x tends to 0. So 1 by x square also tends to 0. Is less than or equal to limit x tending to infinity of x square minus sin x. X square minus sin x by x square minus 2 is less than or equal to limit x tending to infinity of, I'll take x square common, then it is 1 plus 1 by x square, and here also x square common, then it is 1 minus 2 by x square. So x square gets cancelled. So it is, now when I substitute limit x tends to infinity, no, so 1 by x tends to 0. As x tends to infinity, 1 by x tends to 0. So 1 by x square also tends to 0. So I'll write 0. So that means it implies this limit value is 1 minus 0 by 1 minus 0 is less than or equal to limit x tending to infinity of x square minus sin x by x square minus 2 is less than or equal to again 1 plus 0 by 1 minus 0. So it is equal to 1. So implies 1 is less than or equal to limit x tending to infinity of x square minus sin x by x square minus 2 is less than or equal to 1. So that means this limit lies between 1 and 1. It lies between 1 and 1. So that means its value is equal to 1. So it implies that limit x tending to infinity of x square minus sin x by x square minus 2 is equal to 1. That is how we do this problem. Okay. So this is the method. So put a, so you will write is equal to 1 is equal to 1 according to the sandwich theorem. According to the sandwich theorem. According to the sandwich WICH sandwich theorem. And you state this theorem. This theorem you please state here. You write it here. You write it here and write the. So you have this limit. So because we cannot put x is equal to 1 by y and do this problem, you have to use sandwich theorem. Generally, this type of problems will have either sin x, cos x, or cos square x like that. So we always start like this: sin x or sin x lies between minus 1 and 1. If you have sin square x lies between 0 and 1. If you have cos square x, it lies between 0 and 1. Sin x and cos x lie between minus 1 and 1. So even you have minus x, it is again this almost same relation. For cos x also it is same. So you try to bring this expression from here, from this step. Sin x, then minus sin x, then x square minus sin x, then divide by x square minus 2 and get an equation. And then apply this limit. Whatever limit is there here, you apply that limit and then find the limit. Left side, right side values, mostly you have that problems only, that type of problems only. So they will be equal. So the limit value is equal to 1. So like this we do. Okay, now we can try these problems if possible. Okay, you can try this problem, homework. You can try limit x tending to infinity of 2 plus sin x, same type of problem, 2 plus sin x by x square plus 3. So your answer is 0. Answer is 0. And then even this problem, limit, first compute, all these are compute or find the limits. Okay, now second problem, limit x tending to minus infinity, whether it is plus infinity or minus infinity, the procedure is same. Minus cos 3x by x square plus 5. So the answer is 6. Answer is 6. You can try this problem. Here also cos 3x lies between minus 1 and 1. Same type of steps. So cos 3x lies between minus 1 and 1. Minus cos 3x lies between minus 1 and 1. That also you'll get. Then add 6x square on both sides. 6x square minus cos 3x. Okay, add 6x square. Then it is 6x square minus 1. So 6x square minus, this is also minus cos 3x is less than 6x square minus 1. Then divide by x square minus 5 plus 5. Divide by x square plus 5. X square plus 5. Now apply limit x tending to minus infinity. Take x square common. Then it is 6 minus 1 by x square. This is 1 plus 5 by x square. 6 you will get. Here also you will get 6. So you can try these problems. Then one more problem is there. I'll give that also. So next you can try this problem also. Limit extending to infinity of 2 plus cos square x by x plus 2007. So here you should start like this. The answer is 0. So here you should start like this. Cos square x lies between 0 and 1. Because it is square quantity, it is always positive. So it lies between 0 and 1. Like that you uh, start, add 2 on both sides, 2 to the inequation, divide by x plus 2007 like that. And then, so 2 plus cos square x lies between 2 and then this is 3 by x plus 2007 by x plus 2007 x plus 2007. 2007 is looking as a big number, but when you divide, what happens? Now apply limit extending to infinity here. Then this is, when x tends to infinity, this is 0. This is also 0 because we have x in the denominator. So you'll get 0 is less than, so answer is 0 like that. You can try this problem. Now next in next period will be the last period for limits.